All right. Good morning, everyone. So you should have turned in your homework assignment due for today, and you should have done your last warm-up for the week. Remember, tomorrow you have a weekly review quiz. We're going to continue taking a look at lesson 7.7 today. We're going to take a look at the other half of it. Yesterday we learned about simple interest. Today we're going to take a look at compound interest, and we'll talk about the difference between the two here in just a second. So compound interest is paid on the initial principal, the amount, and on interest earned in the past. So as you're writing down this vocab word, I'm just going to tell you guys that when you are thinking about saving money, that compound interest is a lot better to have because you are earning more money with your interest along the way versus the simple interest that we learned yesterday. Simple interest, remember, it's just interest calculated one time no matter how long you've had the loan. Compound interest, it is compounded, could be on a daily basis, could be monthly, it could be on a quarterly basis, or it could be computed once a year. For our purposes, we're going to think about that it happens just once a year when we're doing our calculations. As you guys do more advanced math classes, you're going to take a look at how much interest you would earn if it was compounded 4 times a year, if it was compounded 365 times a year. So you'll take a look at that. So again, compound interest is interest paid on the initial principal, the amount, and on interest earned in the past. This is the way that banks will do your interest, whether you're doing a loan or whether you're doing a savings account. So our equation is A equals P times parentheses 1 plus R to the power of T. So let's take a look at what do each of these mean. The A is a little confusing. It actually has another word to it, but most students will think about that A representing our new balance. So what is the balance of our account after this interest has been compounded? And that's what we're always going to be trying to find in our class. We're always going to try to figure out what that balance is. Just like yesterday, our P is still going to stand for our principal. And I just realized I spelled principal wrong up at the top there in the definition. That is the wrong way to spell principal in this case, but that's okay. So that's how much money we start with, how much money we're borrowing, how much money we're putting into a savings account. It's the amount of money that we're dealing with. R, just like yesterday, stands for our rate, which again is always indicated by the percent. And it's important to note that this is always written as a decimal. So you have to change your percent into a decimal when you're calculating, just like what we did yesterday. And then just like yesterday, our T stands for time, which again is always in years. So that's what our formula stands for. I will always give that formula for you, but you will need to know what the A stands for, what the P stands for, what the R stands for, and what the T stands for, and how to calculate it. So we're going to take a look at why compound interest can be so much better for you if you think about your saving money, and why compound interest isn't your favorite thing if you're borrowing money because you're going to end up paying more interest. You guys don't need to write any of this down. It's just kind of as a talking point to kind of show you the difference between a simple interest and compound interest. Yesterday we talked about simple interest, so we're going to just focus our time in this box to start with. My principal is $1,000. My percent that I'm earning interest at is 4.5%. And I'm going to think about this as a savings account because that's going to help you guys kind of make more sense of it. So I had this money in the savings account for 5 years. After 5 years, we would have earned $225 in interest. Here's our new balance. Okay? Awesome. Now let's take a look at compound interest. Compound interest, first of all, we're going to say it's compounded 1 time per year. That's our focus for our lesson for today, which means let's say December 31st, they're going to calculate your interest, add that into your balance, and then next year on December 31st, they'll calculate your balance again, or how much interest you have. So again, same principal, same percent, same number of years, but now take a look, we're earning $246.18 in interest, and my balance is much higher. Now I know some of you guys are really smart and you're like, Mrs. Haugen, it's $20, and you're probably like, whoopee, big deal. But think about if this was more than $1,000. Think about if it was $10,000, $50,000, $100,000. And you did this for a different number of years, like 10, 20, 30 years. You're going to increase the amount of interest you earn much faster when you do compound interest, especially when it's compounded more often. This next box here is your compound interest, but twice a year. So they'll calculate your interest and give you your new balance, let's say in June and in December. So same principal, same percent, same number of years. But our amount of interest increases just a little bit more than one time, but still more than our simple interest. Compound interest of 4 times per year. This one then they would do in March, June, August, and then December. So do it 4 times throughout the year. Same principal, same percent, same number of years. Again, our interest increases and our balance increases. So compound interest for a savings account is much better because notice that your balance increases when they compound it more often. And again, real life, banks are calculating your interest on a daily basis. They're doing that every single day. So these numbers aren't totally realistic of what you'd see in the real world, but it's just to give you an idea of compound interest with savings accounts are a really good thing. Now banks do the same thing when you're borrowing money, you have a loan. So in that case, for you, it's not such a great thing. That's where banks benefit because that's where then they make their money, to be able to pay interest on a savings account. So that's just kind of some banking information for you guys, and just kind of some information on the simple versus compound interest. Okay, you guys again won't need to know really the difference between them, but besides on how you calculate them. And again, I'll always give you the formula. So let's take a look at some examples. So we're going to find the amount of compound interest to the nearest cent. And again, interest, I have to tell you guys, is compounded annually because we technically get a different answer if it's not stated that way, after the given number of years. So our formula, again, is A equals P parentheses 1 plus R, to the power of T. Looking at our first example, 1,000, that's our principal, that's how much money we're putting in there. 4.5% is our rate. But remember, that has to be changed to a decimal. So I'm going to move it 2 places to the left. So my rate is really 0.045. And my T is years, and my time is given to me in years as well. So it's 2 years. So let's plug in. I don't know what A is. P is 1,000. 1 plus 0.045, because that's the rate, to the power of 2. Now the great thing is you guys are going to be able to type this whole thing into your calculator all in one motion, as long as you're using a scientific one, and be able to get the correct answer with it. On the side here, I'm just going to show you guys how to type that in. So you would type in your 1,000 times parentheses 1 plus 0.045. Then to raise it to a power with that exponent, you're going to hit, there's kind of this up arrow or a caret button, and you're going to type in the number 2 then. So if you guys can help each other out with how you would type that in, but in the end, when you type it in, you're going to end up with $1,092 $2,240.03 for your answer on this one. So if some students are having a hard time specifically with this exponent, with that caret button or up button, see if you guys can help each other out. I believe, I don't have the calculator in front of me, but I think it's a white button for that one, but I'm not 100% sure. So take a look at that one and see if you can help each other out. When you're ready, let's look at our next example. So in our next one, again, plugging into that formula. The dollars is going to be our principal because that's the amount. 6.75, it has the percent sign, so it automatically means this is the rate. But again, it has to be a decimal, so I'm going to move it 2 places to the left, so it'll be 0.0675. Use this whole decimal. Some of you guys like to only use part of it. You need to use this whole decimal in order to get the correct answer on this one. And 3 years, years is my time, so that's my T. So plugging in, we have 2,500. 1 plus, and that 1 is always there along with the plus. 0.0675 to the power of 3. And again, you have to use that little up arrow to the power of 3. Go ahead and type that in. And you should end up with $3,041.19. If you guys have questions on that, try to help each other out so you can come up with the correct answer with that one. All right, we're going to take a look at 2 more examples, and then I'm going to give you guys some to try on your own. In all honesty, students usually just have an issue with trying to type it into their calculator. So they plug into the formula perfectly. Just be careful typing into your calculator. 2,250. That is my P. 6% is my rate. But again, make that be a decimal. Careful making this one be a decimal. Move it 2 places to the left. So it is 0.06. And our time is already in years, so I can use that. Go ahead and plug it in. The nice thing is most problems are written in a way where they get plugged in exactly the same order that you read them. You just have to know that there's that 1 plus and the parentheses. Go ahead and type this one into your calculator. And you should end up with $2,840.57. And again, all of your answers, because when we're looking at money, should always go to the tenths or the cents place, so that's in the hundredths, and make sure you are rounding correctly at this place. All right, our next example. P is 4,000. R is my percent, but again, 2 places, so 0.0425. And T is 1. I want you guys to go ahead and plug this one in and then see if you can come up with the entire answer for me. When everyone's ready, press play. We'll take a look to see if we agree. All right, you should have ended up with an answer of $4,170 for an answer on that one. If people have questions, see if you can help each other out. All right, I would like you guys to go ahead and try these 2 problems here for me. When everyone's done, go ahead and press play, and we'll see if we agree with the answers or not. All right, on the first one, you should have ended up with $1,586.10. One thing to be careful with is make sure that your percent is 0.12, because when you move the decimal point 2 places to the front, it becomes that 0.12%. Then on example F, careful in this one, a lot of students will make a mistake when they're doing 30,000. Make sure you have 4 zeros. Same thing when you're calculating it. Just think about your answer. Like this answer should always be bigger than your principal. And then careful again, moving your decimal point 2 places to your left in your percent. But you should have 0.055 for your percent that you use in the calculation. So your principal, or your balance I should say, after these 5 years in this example would be $39,208.80. If anyone has questions on these two, please help each other out so that way you guys can make sure you are able to do these two, and we can answer any questions that you guys have. When you're ready, here's your homework assignment. It is on the same page that you guys had for yesterday, but make sure you guys are doing 6 through 9, 17 through 22, and 40. Couple quick things. Tomorrow at the start of class, we're going to do a weekly review quiz at the very beginning. And then we'll make our note card, and then you'll have work time on the practice test. And then don't forget that the test is on Monday. And if you're redoing any assignments from, if you're retaking the test from Chapter 6, that has to be done by tomorrow. So if you are hoping to still do that, come in tomorrow morning before school to work on corrections and hope that you get it done during prime time. Otherwise, you guys have the rest of the hour to work, and expect that you guys are working on this quietly.